For today's video, we will answer a geometry challenge given by one of our followers. And the question goes like this. Given a circle and two semicircles, which is tangent to each other, such that their diagonals are parallel to each other, then the question is, what fraction is shaded? Now you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so our goal here is to find what fraction is shaded. So we want to find the area of the shaded region colored in blue and then divide this to the area of the whole circle. So we want first the radius of this two semicircle and the radius of this big circle. If we know those things, we can now answer the question, what fraction is shaded? Alright, so to answer this question, we will draw some chords that connects important points like this. Now, notice this triangle right here. Since the diagonals of these two semicircles are parallel, we can say that this triangle right here is similar to this big triangle right over here. And also take note, one side of this triangle must be the diagonal of the semicircle. Therefore, we can say that this triangle right here is a right triangle. Also, the other triangle on the bottom part is also a right triangle because they are similar. And also take note, this is not just a right triangle. This is an isosceles right triangle. So we can say this length right here, this segment, must be equal to this side. And this side right here must be equal to this side. Now to answer this question, let's call those sides be equal to A and the other side must be equal to B. Now since it is an isosceles right triangle and we know the length of one side, we can say that the length of the hypotenuse must be equal to B multiplied by the square root of 2. Similarly, the hypotenuse of this right triangle right here on the bottom part must be equal to A multiplied by the square root of 2. And also take note, A square root of 2 and B square root of 2 is the length of the diagonals of these two semicircles. Now, we are now ready to find the length of their radius. So, let's draw a perpendicular line like this. Now, what we're going to do is, we know the length of the diagonal of this big semicircle. Therefore, the radius of this big semicircle must be equal to half of its diagonal. So, the radius must be equal to B times square root of 2 over 2. Similarly, the length of the radius of the small semicircle must be equal to A times square root of 2 divided by 2. Now, we are now ready to find the area of those semicircles. And what we need is their radius. So let's first start to the area of this big semicircle. So the formula to find the area of a semicircle must be equal to 1/2 multiplied by pi r squared. Now we know the length of the r or the radius of the semicircle. This is b times square root of 2 divided by 2. Now let's simplify. B times square root of 2 divided by 2 quantity squared. If we square this, we get something like 2b squared over 4. Now, also notice that we can cancel out 2 on the numerator and 2 on the denominator. So, this will give us a value of b squared multiplied by pi divided by 4. This is the area of the large semicircle. Now, using the same method, we can now find the area of the small semicircle and it looks something like this. We have a squared pi divided by 4. This is the area of the small semicircle. Now, we are interested to the sum of the areas of these two semicircles. So, let's add them. So, we have a sub 1 plus a sub 2. This is the area of the big semicircle and the small semicircle. And their sum must be equal to a squared pi over 4 plus b squared pi over 4. Now, we have a common factor here. We have pi over 4 and pi over 4. So, let's factor out pi over 4. This will give us pi over 4 multiplied by a squared plus b squared. This is now the total area of these two semicircles. Alright, so now our goal is to find the area of the whole circle. So to do that, let's disregard all of the unnecessary lengths. So we have here A, B, and B. Now, to find the radius of this circle, we will use one theorem. So if we have two perpendicular chords, given this figure, we can say that the radius of the circle must be equal to just 4r squared, which is the radius of this circle, must be equal to w squared plus x squared plus y squared plus z squared. Now, take note in this figure, we have also two perpendicular chords. And we know the lengths. We have A, B, and this is B, and this is also A. So using those lengths, we can now find the radius of this big circle. So using this theorem, we can say that 4r squared, or the radius of this circle, must be equal to a squared plus b squared plus b squared. Now, let's simplify. A squared plus a squared must be 2a squared, and b squared plus b squared is 2b squared. Now, divide both sides by 2, so all terms by 2. This will give us 2r squared equals a squared plus b squared. Now, we are now ready to find the value of r squared. Let's divide both sides by 2. Now, r squared here, or the length of the radius squared of the circle, must be equal to 1/2 multiplied by a squared plus b squared. So now, we are now ready to find the area of the circle. And we also know the formula. We have pi r squared. We know also r squared. R squared is like this. We have 1/2 multiplied by a squared plus b squared. So this is the area of the circle. We have pi multiplied by 1/2 multiplied by a squared plus b squared, or simply equal to pi over 2 multiplied by a squared plus b squared. Alright, now we can now answer the question, what fraction is shaded? So we will answer this because this is simply the ratio of the area of the semicircle divided by the area of the whole circle. So this simplifies to a sub 1 plus a sub 2 all over a, or a sub 1 plus a sub 2, the sum of the areas of these two semicircles, all over this a, which is the area of the whole circle. So we have pi over 4 multiplied by a squared plus b squared all over pi over 2 multiplied by a squared plus b squared. Now, we can see that we can cancel out a squared plus b squared on numerator and the denominator. So they are gone. This is just pi over 4 divided by pi over 2. Now, if we simplify this can be written as pi over 4 multiplied by the reciprocal of pi over 2, or simply 2 over pi. We can cancel out also the pi on the numerator and the denominator. So, the ratio of the areas of these two semicircles and the circle must be equal to just 2 over 4. And 2 over 4 is just 1/2. Therefore, what fraction is shaded given this figure? And our answer is just 1/2, or half the area of the circle. And as always, we are done.